This is SpaceTime Series 25, Episode 7, for broadcast on the 17th of January 2022. Coming up on SpaceTime, mysteries continue to surround the galaxy's supermassive black hole, discovery of one of the biggest structures in the Milky Way, and Australia's largest rocket engine test declared a success. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that Sagittarius A star, the supermassive black hole at the center of our Milky Way galaxy, is unpredictable, erupting and flaring irregularly not just from day to day, but also in the long term. The findings, reported in the Journal of the monthly notices of the Royal Astronomical Society, are based on 15 years of observational data. Located some 27,000 light-years away, the Sagittarius A star supermassive black hole has over 4.3 million times the mass of our Sun, and is the anchor point around which our entire Milky Way galaxy revolves. Astronomers have known for decades that Sagittarius A star flashes every day, and sometimes gets up to 10 or even 100 times brighter than normal. It's a strong source of radio waves, X-rays and gamma rays, with visible light being blocked by the intervening clouds of gas and dust. To find out more about Sagittarius A star's flares, astronomers searched for patterns in 15 years of data gathered by NASA's Swift Gamma Ray Space Telescope, which has been checking the galaxy's central black hole every 3 days since 2006. This long data set has shown that between 2006 and 2008, the area near the black hole was flashing quite a bit. But then it quietened down between 2008 and 2012 before flares again began increasing. Try as they might, scientists have been unable to distinguish any sort of pattern in the flaring. So exactly how these flares are occurring or why remains unclear. Now, the general consensus has always been that the flares are generated by gas clouds or stars passing too close to the black hole and losing some of their material, which then falls onto an accretion disk where it's crushed and ripped apart before passing the black hole's event horizon to disappear forever as it falls into the singularity. But some of this superheated material and energy is guided by powerful magnetic field lines which shoot out into space and which we see as the flares and eruptions. But there's no real evidence supporting that hypothesis. Nor is there any evidence for another hypothesis, that the magnetic field properties of the surrounding gas and stars are themselves playing a role in the flaring activity. So for now at least, Sagittarius A star gets to retain its mysteries. This is SpaceTime. Still to come, discovery of one of the biggest structures in the Milky Way galaxy, and Australia's largest rocket engine test declared a success. All that and more still to come on SpaceTime. Astronomers have identified what appears to be a massive 3,900 light-year-long filament of atomic hydrogen. The discovery, reported in the journal Astronomy and Astrophysics, could be a possible precursor to a star-forming molecular gas cloud. The filament, which has been nicknamed Maggie, could represent a link in the matter cycle of stars. Measurements suggest that the atomic gas in this lane converges locally to form molecular hydrogen, which, when compressed in large clouds, is the material from which stars are eventually formed. Hydrogen is the most widespread substance in the universe, but detecting individual clouds of hydrogen gas has been a demanding task, which makes research into the early phase of star formation quite challenging. The study's lead author, Jonas Sid from the Max Planck Institute, says that's why this discovery is so exciting. The massive filament extends some 1,600 light-years below the Milky Way's galactic plane. Sid admits he is yet to determine exactly how it got there. But the radiation from the hydrogen, which is shining at the 21 centimetre wavelength, clearly stands out against the background, making the filament easy to identify. The observations allowed sitting colleagues to determine the cloud's velocity in comparison to the average velocity of the Milky Way's disk, finding very little difference along its entire length, which means the filament is a single coherent structure. This also allowed the authors to determine the size and distance of the filament, showing it to be a stunning 3,900 light-years long, at least 130 light-years wide, and located around 55,000 light-years away on the other side of the Milky Way galaxy. The dimensions are incredible, especially considering most similar molecular clouds are usually around 800 light-years long. Hydrogen occurs in the universe in various states. Astronomers find it in the forms of atoms and in molecules in which two atoms are joined together. But it's only in its molecular gas form where it can condense down to form molecular clouds, which then develop cold, frosty regions where new stars are formed. But exactly how the transition from atomic to molecular hydrogen happens is still largely unknown. And that makes the opportunity to study this filament even more important. Scientists have already noticed that the gas is converging at several points along the filament, and this could be where it's condensing into molecular clouds. The authors also suspect that these are the environments where the atomic gas gradually changes into a molecular form. Previous evidence suggests that about 8% of Maggie's mass has already been transformed into molecular hydrogen, and so these areas could be where new stars are born. This is SpaceTime. Still to come, Australia's largest domestically built rocket engine test declared a success, and Earth's volcanic hotspots are turning out to be surprisingly cool. All that and more still to come on SpaceTime. Gilmour Space Technologies say they're still on track to reach orbit this year with their new Eris rocket. The company greeted the new year with a spectacular 75-second test burn of their hybrid rocket engine. The successful test was a major milestone for Gilmour Space, which is developing a sovereign rocket launch capability that will, over the next 5 years, be capable of launching payloads between 300 and 4,000 kilograms into orbit. Following the successful test, the team will now move into the final engine qualification campaign beginning next month. The 110 kilonewton engine will eventually be used to power both the first and second stages of Gilmour's new 3-stage Eris launch vehicle. The company plans to develop a launch complex at Abbott Point near the North Queensland town of Bowen and is just waiting for final government approvals for the project. Eris Program Manager David Doyle says the Abbott Point spaceport will allow for equatorial orbital launches, with polar launches using the Whalers Way spaceport near Port Lincoln in South Australia.
The test that we just conducted was really about developing confidence and balancing progress versus risk for us in our main hybrid propulsion system on our Eris launch vehicle. So what we undertook was a development test of that system, and we're looking at how the propulsion system, the engine, performed against our expectations of the design based on previous tests and detailed analysis that we'd previously undertaken, and making sure that everything matched up against our expectations, which it did. And that really is, like I said, about developing confidence and allowing us to be able to proceed forward into the next stages of the launch vehicle's development program and on to launch as well.
I guess the real test will be to see whether or not you can maintain an engine burn long enough to match the amount of time the first stage of the rocket will need to fire if it's on an actual orbital ascent.
Yeah, that's a very astute observation and question. But yes, 100% correct. That's really what qualification is about for us for the main propulsion system, and indeed for all of the components and systems that go into the vehicle. We run through qualification testing of all of those components and systems. So this successful test now allows us to move into the qualification campaign coming up in the next month, and that is the point at which we will be putting the hybrid main propulsion system through the full envelope that we can expect, which includes, as you pointed out, the full mission duration for the first stage.
You talk about a hybrid engine. What makes this one hybrid? You're using what, liquid oxygen? And I know the original plan was for a 3D printed pelletized fuel.
Yeah, so generally speaking, hybrids bring together aspects of solid propulsion technology and full biopropellant or liquid propulsion technology into a hybrid form. So it can either be a liquid oxidizer and a solid fuel, or a solid oxidizer and a liquid fuel. In this case, we use a liquid oxidizer and a solid fuel. And as you pointed out, we had in the past utilised 3D printing technology for that solid fuel, but we've moved on and learnt and improved based off our understanding lessons, and have adapted that fuel to its current form, which unfortunately I can't go into in great detail, but it's certainly meeting and exceeding our expectations in terms of the performance, and through this test is another great example. The data we received gives us full confidence in the makeup of our propellants, so the liquid oxidizer and the solid fuel, to get what we need out of this propulsion system.
And I know one of the goals was to make sure that you could throttle the fuel up and down to meet performance parameters.
For the just a little bit, they said throttling up and down of the main engine.
Yeah,
look, it is a capability that is extremely useful for different profiles and different trajectories, which is the objective, obviously, for us to be able to give our current and future satellite customers the opportunity to access a range of different orbits with our vehicle. And so, the design is capable of that, and we are certainly going to be able to provide that with our main propulsion system. Yep.
Now, whenever one builds a rocket engine, history has taught us that timelines don't really work. But what's your dream? What's your hope as far as getting to orbit's concerned? Are you still looking at this year?
As the head of the launch vehicle programs in the company, I always want everything yesterday. So I'm pushing the team extraordinarily hard here inside of Gilmour Space, and also working very closely with the suppliers, because we have an enormous Australian domestic supply chain that we work with, and also some key suppliers internationally, which have been hit by COVID as well. So, we've had issues there in terms of the logistics and broader international supply chain. So we're working very closely, and like I said, I'm pushing them very hard, and still very much on track for getting at least one, but ideally two launches done this year. And, we're on track for that, very much so. One thing I will say is that from a launch vehicle perspective, that's one aspect of what we need in order to be able to launch, particularly from Australia. The other side is equally, if not more important, which is the launch site. And so, not only are we designing, manufacturing, testing the launch vehicles that will launch from Australia, but we're also developing and commissioning, and we'll operate a launch facility from the Bowen region up near Abbott Point in northern Queensland to be able to launch as well. So we've got to get the launch site operational in time to be able to receive the launch vehicles, carry out commissioning activities, and then ultimately launch as well. And so that could present additional risks to that timeline to launch this year. And we are working very closely with partners in local, state and federal government to try and realise that launch site aspect is a really important part of the success story for us to be able to launch this year.
What's involved in construction of a launch facility? You need a hard stand, you need an assembly building and something like that. You need some sort of facility for liquid oxygen in this case. What's actually involved in building something like that?
But from a minimum viable product, or an MVP as we call it, there's actually not a huge amount that's required from an infrastructure standpoint to be able to get an operational launch site. So as you pointed out, you need a concrete pad, hard stand, or the launch pad. Doesn't need to be overly thick. You can divert blast away, and the size of vehicles that we're building at the moment, it's categorised as a small lift launch vehicle. It's not overly impactful in terms of concrete pads, launch tower, gantry, hydraulics to be able to lift and restrain the launch vehicle through the launch. As you pointed out as well, integration building, which is a big shed that you can keep air conditioned up in northern Queensland during the summer and winter, and then also keep reasonably clean. And then the only other aspect to the launch site is a launch control facility, which is separated from the integration building, the pad, away so that you can effectively operate the vehicle, the pad systems, and be able to conduct the launch safely and effectively and stay in touch with not only the vehicle through ground-based telemetry receivers, but then also local authorities, state and federal authorities and agencies and other bodies that are important stakeholders and are potentially impacted by the launch operation. So 2 sheds, some reasonably high-tech telecommunications equipment, thick concrete pad and some steel infrastructure and hydraulics. And then, like you said, the only other thing there is that goes in with the pad is the propellant storage, which coming from a reasonably solid oil, gas and mining background as a nation, we've got the capability to be able to store propellants and pipe those around in a small facility in spades. So that's really not a big thing for us as an industry, if you like.
Now, you're looking at Abbott Point, as you mentioned. That, of course, happens to be one of the major coal export points in Australia, so there's rail infrastructure there. You need good road infrastructure as well, and undoubtedly, once you get up and running, all sorts of little hang-on industries will start to build up in that area.
Yeah, absolutely. And look, I think it's a really, really important point that you make about the potential for adjacent industries. So not just with the launch site, but with everything that we're doing as an organisation, designing and building the launch vehicles, engaging with the supply chain here locally in Australia and helping businesses and companies that are non-conventionally and not associated with aerospace and space at all realise their potential to support an industry which is exploding internationally and really starting to gather momentum here in Australia. And it gives them opportunity to pick up and some of the investment that's coming from the private sector as well as the public sector in the growth in the industry, and particularly up there in Bowen. It's not known as the Space Coast. We hope to make it like Kennedy is as a great tourist attraction to be able for people to be able to come and see the launches, which they will be able to do up there. So tourism industry is going to get a big kick out of it, but then also helping businesses and industries that are attached to and reliant on things like mining or single source supply. We can give them another option to get revenue in, and that's certainly our intent, is to engage those local businesses up there and to help them grow with us as we grow the capabilities there and in the country generally.
And of course, as well as Bowen, there's also Southern Launches facility now being tested, hopefully, being tested on near Port Lincoln in South Australia. And you've got the option of a third facility in Arnhem Land, although they're initially doing sounding rockets there.
Yeah. Look, I think it's fantastic, and I'm really enthusiastic and happy to see other organisations and idea generators around the country, not just Southern Launch and Equatorial Launch Alliance up in Arnhem Land and Northern Territory, sort of surging forward and making a positive name for the space industry in Australia. Absolutely, as you point out, those launch sites, those launch capabilities will hopefully be operational in the not too distant future as well. And we'll certainly and are certainly engaged with Southern Launch and Equatorial Launch Alliance about what the potential is to be able to utilise those sites and what it might look like as a relationship going forward into the future. We need another launch site. We can't operate exclusively out of Bowen. The geography, and as your listeners will be able to explain to me far more than I understand at the moment, the geography of Bowen Orbital Spaceport will not give us access to the wide range of inclinations through a direct orbital insertion it would give us. So we do need other sites on the southern coast of Australia, like Southern Launch's site down at Whalers Way. That presents great opportunity to be able to access high inclination orbits like sun synchronous orbits, ammonia orbits, and also polar orbits as well.
With the Abbott Point facility, you're pretty well restricted to launching due east because you've got to get far enough to make sure that the first splashdown site is well beyond the barrier reef.
Yeah, exactly. So the barrier reef has been the forefront of our considerations ever since the Queensland State Government identified the Amber Point site as a highly suitable location for small lift launch vehicles. It's incredibly important to us. We see the significance and understand the significance of the Great Barrier Reef as a World Heritage listed region and as an important asset to Australia and to the businesses in Queensland for tourism as well. So with that consideration, environmental impact assessments and engagement with experts that we've done over a lengthy period of time, and we understand and have analysed the risk is extremely low. Or the potential for impact to the reef is extremely low. And like you said, taking into consideration things like where our expected splashdown points are for our first, second stages and the fairings as well clear of the Great Barrier Reef and no impact to that at all. But going back to the available azimuths, launch azimuths to get out of Bowen Orbital Spaceport, the reef is an extremely high consideration for the different inclinations that we can access. But then also there's downstream or downrange considerations like the Solomon Islands, the Marshall Islands, and our Pacific neighbours as well down there as well. We certainly don't want to be leaving any rubble or wreckage behind that could potentially cause safety hazard for other nations as well. So lots to consider. They're going to a launch site, but we're very, very happy with that site in particular. The technical assessments that third parties have done, the Queensland State Government, what we've done, are all giving us a lot of positives and green lights. And yeah, we're full steam ahead. But like I said earlier on, we really do need that additional lean in from local, state and federal government to make this happen with us and as a nation by the end of this year.
Is there a specific hold-up point? Is there a specific level of government that's causing problems?
I wouldn't say there's any one particular area of any one level of government that's holding us up. I think in general, all levels of government are enthusiastic to see this happen. What we're really calling on is just an increase in a heightened sense of urgency. There's no time like the present. If we want to make this happen this year and we want to capitalise on the momentum internationally and globally behind the development of space economies for countries, we really need that increased sense of urgency at all levels, and any form of support to the launch site, the approvals for the launch site will help us achieve that goal of a launch in 2022 and hopefully multiple launches in 2022.
One big difference between what you guys are trying to do and what Southern Launch and Equatorial Launch are aiming at, you're also building up a sovereign launch capability in terms of an actual launch vehicle. Tell me about the rocket.
Yeah, so Eris is the name of our launch vehicles. Eris is designed to be able to lift up to 300 kilos to low Earth orbit and up to 150 kilos to high inclination low Earth orbit. It's a 21-metre tall launch vehicle, so quite a big rocket in the scheme of the small lift launch vehicles. So taller and wider at 2 metres in diameter at the base, tapering down to 1.5 metres the upper sections, the stage 2 and the payload fairing. So quite a larger vehicle than, say, by comparison, Rocket Lab's Electron launch vehicle. It's hybrid propulsion technology that we use on the first and second stages, and we are pretty much at the point now where we're going through and assembling and have all of the main airframe components arriving in this month and next month, and we'll be going through and assembling all three stages of the launch vehicle in the next 2 to 3 months. And then, as I mentioned earlier on, just going into the qualification testing for pretty much all of our components and subsystems in parallel, looking for that launch coming up in middle to late this year.
Now, you just mentioned Electron. They're, of course, going to be your main competitor in this part of the world, at least. With Rocket Lab, Peter Beck's just announced his new Neutron rocket, which is Electron's next stage up. You're not at that level yet. Are you thinking about it, Pat?
Yeah, look, we're an incredibly ambitious organisation, company, and Adam Gilmour, CEO, is incredibly ambitious as well. And I think the ethos that we employ here is to always continuously improve. And so that goes for the rockets that we design and build here. So with that, shadow of doubt, we're going to go to larger lift launch vehicles that'll be able to service geostationary orbit, lunar orbits. We have ambitions to be able to deploy rovers and payloads to the surface of the moon as well. And then ultimately beyond, we really want to take Australia as a spacefaring nation into low Earth orbit as a priority for geostationary to the moon and then beyond to Venus, Mars and out into the broader solar system.
That's Eris Program Manager David Doyle from Gilmour Space Technologies. And this is SpaceTime. Still to come. A new study has found that some of Earth's volcanic hotspots are actually surprisingly cool. And later in the science report, Australia records its hottest day in 62 years, with the temperature reaching a blistering 50.7 degrees. All that and more coming up on SpaceTime. A new study has found that some of the so-called hotspots, which create volcanic islands like those of Hawaii and Iceland, are actually surprisingly cool and may not originate from active larval plumes in Earth's deep mantle. The findings, reported in the journal Science, challenge the classical mantle plume theory for the origin of hotspots. Generally, there are two types of volcanism observed on Earth's surface. The dominant type occurs where the tectonic plates meet. This causes friction and heat and is driven by the large-scale convective circulation of the planet's mantle. The other type occurs as isolated intraplate hotspot volcanoes. These are thought to be fed by hot, actively upwelling plumes rising up from the very deep mantle, possibly right near the core mantle boundary, with excess temperatures roughly 100 to 300 degrees Celsius higher than those volcanoes located along mid-ocean ridges. The problem is, excess temperature estimates for volcanic hotspots are actually rather limited in geographical coverage and are often inconsistent for individual hotspots. To determine whether oceanic hotspots are indeed hotter than ridges, scientists converted seismic velocity measurements for oceanic ridges and hotspots into temperature. And contrary to previous assumptions, they found that some hotspots are surprisingly cool. Now, according to the authors, while about 45% of plume-fed hotspots are hot, with excess temperatures of at least 155 degrees Celsius or more, another 40% are simply not hot enough to actively upwell from the deep mantle. They also found that 15% of so-called hotspots are actually cold, with excess temperatures of only about 36 degrees or less above that of an average volcano. The authors suggested the cooler hotspots may instead originate from the upper mantle, or they're fed by deep plumes that are entrained and cooled by small-scale convection dynamics. The debate goes on. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australia has recorded its hottest day in 62 years, with the temperature reaching a blistering 50.7 degrees Celsius in the remote northwestern Australian coastal town of Onslow. That's 123.26 degrees Fahrenheit on the old scale. The Bureau of Meteorology says the new temperature equals the old record, which was recorded at Oodnadatta in outback South Australia way back on January 2nd, 1960. Climate Council Research Director Dr. Martin Rice says the extreme temperatures are all part of a long-term warming trend driven by climate change. Summer temperatures in the mid-40s are already becoming commonplace in Sydney, and Rice says both Sydney and Melbourne will see 50-degree summer days in the next decade. For the record, the current official record for the planet's hottest temperature is 56.7 degrees Celsius, that's 134.1 degrees Fahrenheit, which was recorded on the 10th of July 1913 at the aptly named Furnace Creek Ranch in Death Valley, California. A new study has found that the COVID-19 coronavirus could spread more quickly among people exposed to higher levels of air pollution. The findings, reported in the Journal of Occupational and Environmental Medicine, looked at the spread of the virus at the start of the pandemic in northern Italy, where they had data on the amount of air pollution residents were exposed to based on their home addresses. Researchers found that for every percentage increase in long-term exposure to airborne particulate matter, there was a corresponding increase in cases of COVID-19 infection. Meanwhile, a study in the New England Journal of Medicine has found Pfizer is 94% effective in preventing hospitalization as a result of the virus in teens and 98% effective in preventing a stint in intensive care. Researchers looked at the vaccination rates of a cohort of 445 COVID-19 patients aged 12 to 18 and compared them to similar cohorts who were in the hospital system for a non-COVID-19 medical issue. They found 4% of the teens hospitalised with COVID-19 had been fully vaccinated, compared to 36% of teens hospitalised for other issues. Just 2 COVID-19 patients in ICU had been fully vaccinated, and all 7 COVID-19 related deaths were unvaccinated. Over 5.5 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be at least double that amount, with more than 315 million confirmed cases. A 57-year-old man in the United States has become the world's first person to receive a transplant of a genetically modified pig's heart. The surgery was undertaken at the University of Maryland Medical Center. The genetically modified heart had cell surfaces lacking a sugar molecule called alpha-1,3-galactose, or AGAL, which triggers the human immune system response. The man also received a new experimental drug designed to stave off rejection. Well, forget all those lies you've heard about goldfish being dumb. Scientists have successfully taught a goldfish to drive a car. The experiment at Israel's Ben Gurion University was designed to understand the navigational abilities of animals. Scientists placed a goldfish tank equipped with sensors on a robotic motorized vehicle. The fish was then taught that swimming in a certain direction would cause the vehicle to travel in the same direction, resulting in a food reward. The findings, reported in the journal Behavioral Brain Research, show that the goldfish's navigational ability supersedes that of its water environment. And you can see the goldfish drive on the SpaceTime Tumblr blog. It's been revealed that in October 2019, 19 out of the top 20 Christian websites operating on Facebook were fake and were especially designed to manipulate and foment discord among the US population. The findings are detailed in an internal Facebook report which has been publicly released by MIT, the Massachusetts Institute of Technology. The findings show how most religious websites were secretly created by Eastern European troll farms. They used stolen religious content from legitimate Christian websites, which was then reposted on their site to attract large numbers of unsuspecting people. But these websites were also sprinkled with partisan political propaganda designed to influence voters and turn people against each other. And the Christian pages weren't Facebook's only top-ranked fakes. The majority of the most popular pages for African American and Native American audiences were also created by troll farms in Kosovo, Macedonia, and other Eastern European countries, working in a coordinated campaign designed to provide provocative content and political propaganda. Tim Mendham from Australian Skeptics says the troll farm fake websites were reaching a staggering 140 million people a month.
Yeah, this was a study done in the US primarily, where Christian Facebook pages are a lot more popular than they might be here. They looked at the 20 top most popular Christian Facebook pages, and 19 of them were fake. In other words, they were set up by not necessarily Christian people, but I mean people in the Eastern Europe especially, to repurpose or reuse information from other Facebook pages or wherever they want to get it from, and creating these fake Christian Facebook pages with all sorts of believable names that might be impressive to Christian people, and feeding them not just Christian messages, but also disturbing messages and encouraging sort of prejudices and things like that to actually disturb the equilibrium of the American population. Everything from obviously sort of anti-gay marriage, the left-right sort of disparity, evil socialists, evil sort of extra-right people. All these things were being thrown in amongst these Christian messages. And what these people found out was that the Christians themselves weren't being very critical analysis of the pages. Because they were Christian, they tended to believe it, because after all, Christians wouldn't lie. But at the same time, of course, because they were that popular, and this is the 20 most popular sites, they're obviously the people who set them up made a lot of money out of ads and that sort of thing. In fact, these
troll farms.
Yeah, the troll farms or whatever, but they're making millions, if not billions, of money out of these fake sites. So the issue is applying some critical thinking is not such a bad thing. It applies to everybody. It applies to all sorts of Facebook pages, but people tend to believe that perhaps what some of these sites are saying might not be true, but the sites are genuine. And in this case, they're saying the sites weren't genuine, or the pages weren't genuine on Facebook. So, gee whiz, basically they say, you've got to look at things like you have to find out who created the content. How did they create the content, like stripping information off another, or skimming information off another site? What do they do with this content? Why are they creating this content? All those things are questions that are very hard for people to apply all the time.
A weaker America is a weaker world, let's face it. We're seeing the fruits of that now with both China and Taiwan and also Russia and the Ukraine.
Yeah, but it seems almost as if America doesn't need a lot of help to cause inner tensions, etc. I mean, they've always had a lot of problems ever since America, basically. I mean, and well before social media was on the scene, the Americans have been doing terrible things to each other, as have a lot of countries.
Even with what's happening today, I keep thinking of McCarthyism and even going back further to the Salem witch hunts. It's all the same sort of theme that keeps cropping up over and over again.
Even without these troll farms and things, they can still encourage discontinuity in beliefs and sort of prejudices and that sort of thing, which can be manifest in the most serious ways, as we've seen over the years.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.